So we were talking about the diffusing capacity and how from the Fick's law we've taken the area times the diffusion constant divided by the thickness into one number, which is the diffusing capacity of the lung, DL. And if we rearrange the formula for DL, it would be now for carbon monoxide, we've talked about how the partial pressure in the capillary is extremely small. So the P2 in this equation is close to 0, so we can ignore this, bringing our final formula to look like this. The A standing for the partial pressure of the carbon monoxide in the alveolus. The units for DL is the rate of transfer, which is in mils per minute. And we can see that this is divided by the pressure in the alveolus, so this is mils per minute per millimeters of mercury. The normal diffusing capacity is 25. Now I want to finish this talk with a final point to add about diffusion capacity. So far we have only focused on the alveolar wall. On the left being the alveolus, and on the right the capillary and the red blood cell within the capillary. We've previously alluded to the importance of hemoglobin and its importance as acting as a sink for the oxygen. Now, if we were to consider the oxygen from moving the alveolus into the capillaries, now we have two steps. The initial step is its diffusion through the alveolar wall, which we will call DM. Secondarily, we have the time that it takes for this reaction to occur. The rate of this reaction occurring is the same as that of the diffusion capacity. That was mils per minute of oxygen per millimeter of the partial pressure of oxygen, but with the addition that this is per 1 mil of blood. And we describe this rate as theta. Now because theta is per 1 mil of blood, to get the total rate of reaction of O2 with hemoglobin, we multiply the theta by the volume of blood in the capillaries. So in conclusion, the total diffusion capacity of the lungs is the diffusion capacity of the alveolar membrane plus the total rate of reaction between the hemoglobin and the oxygen. And that's the end of the talk. Thanks.